everybody. Today we're going to learn about something called CPCTC. So first, just make sure you're on the right page. It's lesson 5 in your packet. It looks just like this. And let's start by filling out some notes. So after two triangles are proved to be congruent, it can be concluded that any remaining pair of corresponding sides or angles are congruent. This is known as corresponding parts of congruent triangles are congruent, or CPCTC. What this is really saying is this. If I have a pair of triangles, so let's say triangle ABC, I'm just going to call this one DEF. Let's say that I prove these congruent by side, angle, side. So I figured out the triangle ABC is congruent to triangle DEF by side, angle, side. Now that I know that these two triangles are congruent to each other, I can say that all the remaining sides or angles are also congruent. So I can say that AC is congruent to DF. I can say that angle A is congruent to angle D. And I can say that angle C is congruent to angle F. Those are just the remaining sides and angles. Okay, so we're going to use this in proofs. So to prove that a pair of angles or segments are congruent, the first thing we do, we select a pair of triangles that have these parts. Then we prove that these two triangles are congruent. And then we conclude that the required parts are congruent because the corresponding parts of congruent triangles are congruent, which we can abbreviate as CPCTC. So let's look at a proof with this. So notice we have some givens, and we also have a prove. We want to prove IE is congruent to KM. We want to prove these segments are congruent. It no longer says we want to prove two triangles, it says we want to prove these two segments. So on your side, you have some hints. So let's look at these. I'd like you to write them down in the little box, because I think they're very helpful. So it says to reason backwards from what you are trying to prove by answering these two questions. So write this down. Which triangles contain IE and KM as parts? So let's figure that out. We want to prove IE, highlight that, and we also want to prove KM. We want to prove that those two segments are congruent. Well, what triangles contain that? You can see IE is contained in triangle IEM. And you can see that KM is contained in triangle KME. So those are the two triangles that we are going to want to try to prove congruent before we can do our final step, which is our proof. Okay? Question 2 says, how can these triangles be proved congruent? So now we know we need to prove triangle IEM and triangle KME. We need to prove them congruent to each other, and we need to use the givens that we have. I'm going to redraw these triangles out. Redrew them. And let's look at what we have for our givens. I have MI congruent to KE. So I drew it on both diagrams, the one that's together and then the one I separated. I know angle IME, that's here, is congruent to angle KEM. That's here. So that means I have two things, but I need to get three things. So if you notice, there's a reflexive of ME. Here and here. They share that. So then I can just start by filling in my proof. You can see that these two triangles will be proved one of our normal 5 methods, side angle side. So I need to do that first. Okay, so let's do that first. So you see the proof down here at the bottom. We start by saying MI is congruent to KE. That's given. And we have the angles that were given. angle IME, congruent to angle KEM. And then we know that reflexive. E is congruent to ME, reflexive property. Now I have enough, right? I have a side, I have an angle, I have an upper side. I can prove those two triangles. Triangle IME, congruent to triangle KEM by side, angle, side. Now here's my last step. This is the new part. Now that I know that these two triangles are congruent, I know that all the remaining parts of them are also congruent. So I wanted to say your proof, we look at our proof, IE congruent to KM. Well, now I know that IE is congruent to KM because of that CPCTC. Corresponding parts of congruent triangles are congruent, and you can abbreviate it in your proof. We're going to do one more. So just flip to the back. And let's look. We have our givens and we have our proof. We want to prove AB is congruent to DE. So it might be a helpful hint for you if you highlight the pieces you want, and maybe you even want to highlight them in different colors. AB congruent to DE. All right, so which pair of triangles contain them? I'll even write that question out. Which pair of triangles contain AB and DE? AB is contained in triangle ABC, and DE is contained in triangle EBC. So that's the triangles that I'm going to be looking to prove. I'm going to be looking to prove triangle ABC and triangle EDC. So let's do that first. All right, so we're given that C is the midpoint of AE and BD. C is the midpoint of both of these. So that means that EC is congruent to AC and DC is congruent to BC. And C is the midpoint of both of those segments. Congruent to BC. You also know that BC is congruent to DC. I'm just going to write them both in step 2 because they have the same reason. A midpoint divides a segment into two congruent segments. You could write them both separately, but then you'd have to write this reason twice. That gave us two sides. We still need one more thing. You know, we look for reflexive or vertical angles when we're out of givens. Well, in this case, we have vertical angles. I'm going to call them 1 and 2. We're going to say angle 1 is congruent to angle 2. By reason, we know intersecting lines form congruent vertical angles. That's enough. That gave me side, an angle, and a side. So our method is side and side. So triangle AC is congruent to triangle ACD. And that's side, angle, side. It's congruent to side, angle, side. And now I can go to my proof. Now that I know my green triangle and my yellow triangle are congruent to each other, I know that all the other pieces in there are also congruent to each other. That's what CPCTC means. Once I proved the green and the yellow triangle, I know that AB is in my green triangle and DE is in my yellow triangle. And since triangles are congruent to each other, all of their parts are congruent to each other. So I can say, in my last step, AB is congruent to DE. And that's my CPCTC. Corresponding parts of congruent triangles are congruent. Okay, and that's all for now. We'll practice some of these in class tomorrow.